Podcast is now starting. All attendees are in.
Then we'll start the recording, and there we're ready to go. Good morning, good afternoon, good evening to people around the world. This is Martin Hubel, your host of the Db2Night Show. And today's our first ZOS show for the fall. We've got a special guest with us, once again, Roy Boxwell of SEGUS, or SEG, depending on what side of the pond you're on, I guess. How are you doing today, Roy?
I'm part of SEG today, I think.
Oh, okay. Yeah, it switches from day to day, doesn't it?
It depends on what time zone I'm currently in, yeah.
Good stuff. All right, so let's get our little administration out of the way so we can get on with the show. And we'll move forward here eventually. There we are. Here's our standard social media. We are on Twitter, and I try to remember to send out tweets. Sometimes I do, and sometimes I'm a quiet tweeter. But I'm going to have to remember to do more of that. We have our LinkedIn group. And then we have our standard disclaimer here where mind your manners, everything's being recorded. You can get the replays. The trademarks belong to who they are. And so there. And we also have a question and answer tool, which people should hopefully are familiar with. If you've watched the show before, you can ask questions by typing them into the question tool, and I will break in and pass those on to Roy as needed as we go along. So with that, let's move along. And there's our agenda as always. There we've got the legal stuff out of the way. We'll have some quick announcements, do our polls, and then we'll turn things over to Roy. And so the show's coming up. In 2 weeks, we have another LUW show coming up with John Hornibrook. I believe this will be his first show on the Db2Night Show, but he's a long time presenter and contributor to the DB2 community. He works in the IBM Toronto lab on things related to DB2 performance, it's been lately on statistics, and he has some really good insights. He's a guy that you'll really want to hear. And then we have on November the 8th, we have the fabulous Amber Crooks, who will go through DB2 health checks for DB2 LUW databases, and we'll finish off on December 13th with George Backlars, once again of the IBM Toronto lab. George is a longtime friend of the Db2Night Show, and we always look forward to hearing what he has to say. On the System Z side, we have today's show, and on October the 11th, we'll have Patrick Bossman talking about a show and tell on agile development practices with DB2 for Z. That'll be a fantastic show. You really want to hear that one. Then on November the 15th, we actually are having our October shows a little early because we have iDoug in the middle. And so following that, we're back on November the 15th. And then we finish off with Tony Andrews of Themis, who normally does SQL type topics. I haven't got his abstract yet, but we've had Tony on before, and he's also great. So I'm really excited, and I think you should be as well, of the quality of speakers we have this fall. So it's just absolutely great. Once again, DBI is the founding sponsor of the Db2Night Show, and I would like, if you're interested in learning more about their products, they have a little performance webinar they've taped, and you can follow a link from the DBI homepage to the demo. And if you watch it, they give you I believe a Starbucks coffee card or something of that nature. If you need a shot of coffee, go there, watch the demo, and you'll get a card to get one. Here are our sponsors, DBI, as I mentioned, and yours truly, Martin Hubel, Martin Hubel Consulting, Inc. And moving on. Now we're going to do our polls. Let me get the polls up here. Roy, I took the questions you sent along, and I adapted them a little bit. Well, you know, things have to fit into a multiple guess. I'm sorry, a multiple choice type thing for our survey. So the first one is the standard, what version of DB2 are you running? And you notice that I've got, I've moved this up. Anything older than version 11 conversion mode is now lumped together, new function mode, and then we have various levels of version 12 functions, 100 or 500, 501, 502 seem to go together, and then 503 or higher. So the people that are really starting to exploit new functions in version 12. And 85% of our audience has voted, so we'll close that off and share the results. And we see that about half of the audience is still on version 11. 38% have gone to 100 or 500 function level, and we have 13% of our audience who are avant-garde new adopters of function level 503 or higher, and we also have a 501 and 502 represented as well. Okay, next question. Do you have the plans to use the relative page numbering? I took these two questions and put them together, Roy. We have we use it, we plan to use it, we know what it is, but now have no plans as yet. And the last one is, what is it? I noticed that Håkon Roberts of the SVL had actually written something up, and it was available on the IDEC website. I just wanted to have a look and see what was being said about it. And folks, launch. Thank you there, Chuck. You're so helpful. Martin forgot to click the button. There, that's better.
That looks better.
Yeah, that's found on many cockpit voice recorders, you know. What does this button do? Good thing I got friends out there that tell me what I need.
I wondered. I thought it was my machine that was lagging.
No.
I'm a long way away
I
over the
can
pond. Yeah, I was thinking, perhaps the electrons are taking the long route.
I can lag all by myself. Thank you very much. And, we're getting some interesting answers on that. It looks a lot better after you click the right button, and so you don't have anybody using it now. We've got about 30% of the audience say they plan to use it. 43% is they know what it is but have no plans as yet, and 30% say, "What is it?" So that's good to know. All right, we'll hide that, and I'm going to try to remember to click the button here. Now let's do this one. Use sequences. And the nature of the question you sent me, Roy, kind of.
Yep.
Is, we use them and we review them occasionally to make sure they're still accurate and correct. But it's interesting. People define them and they just figure they're going to work, so they don't look at them afterwards.
Absolutely. That's the joy of a sequence, really.
Yeah, and then we have no, and then 21% need more information. About the same 74% have voted, so I'll share that with you. 50% are using them.
Good.
Yeah, 50% are using, but they rarely look at them after they're defined. 14% yes, and we review them occasionally. And then we have 14% at no, and 21% would like to hear more. That was a good question, Roy.
That was a good question. Oh, I'll get myself a beer for that one.
Yes, yeah, and it's beer o'clock over there, isn't it? It's 5 o'clock in the afternoon.
Very close, dangerously close.
Finish the show first. We want to make sure that
Exactly.
the quality of information doesn't deteriorate as the show goes on. Have you ever hit a max partitions limit?
Mm-hmm.
We got some answers in on this, and it looks like a good one here. And we're about 60% voting. I'll give people about another 10 seconds. There we are. All right, we'll close this one off. We're at 80% voted. And what we see is 31% of our audience has hit it, 19% expect they might hit it soon, and 50% say not likely. Interesting. All righty. Those are all kind of fun and good. So with that, I'll go back over to, I should be seeing the move of your mouse screen right now. I'll go over here and click you should be seeing a wonderful picture of yourself there, Roy.
Ah, the good old days when I had a lot less grey hair.
As a Lord, it's hard to be humble, isn't it?
I think I'm going to have to send you a new photo.
Yeah, I got a funny story for that, but it's probably not one that should be on a recorded broadcast. But I had this really picture, and the presenter said, "That's a young man that I no longer recognize." So they sent me this other picture, and I went, "Who is that?" It was fun. All right, so I see your screen now, DB2 for ZOS, know your limits, and we're ready to go. I'll be watching the question tool.
Okay.
I'll break in, but in the meantime, I'll mute myself in case my co-host goes off.
Okay. So, thank you very much for joining the first of the ZOS night shows in the fall this year. I'm going to discuss limits. This formula here might take some of you who are watching back to a terrible time in a maths class at university or polytechnic or high school. Basically, it's a limiting function. We are all aware that everything has limits. Everything has limits. There's no such thing as no limits. Lots of people try and spin DB2 on Z and LUW and saying, no, we have no limits. You can do what you like. We all know that's not really true. There are always limits. There always have been, there always will be. So my little agenda, limits through the machine, limits through logic, limits through design, future directions. Obviously, I'm not an employee of IBM. The future directions is just my wish bucket list, my bucket list, if you like, and possibly what I would love to see coming out in future versions or FL levels of DB2. So, first point, limits through the machine. What have we got? People say that space is infinite, which is true up to a point. And the same, of course, is true for DB2. Let's now imagine that you have an infinite amount of disk space and you have an infinite amount of memory. What limits could there possibly be for you? Now, the first reaction is possibly, with infinite disk space and infinite memory, I couldn't possibly have any limits. And of course, you're wrong. Looking at it in historical perspective, in the beginning was the vSAM cluster. Now, the vSAM cluster existed before DB2 walked the earth. But of course, one day, DB2 was invented and they used vSAM clusters. This is even older technology than I am, which is quite impressive these days. The size limit, of course, of a vSAM cluster was 4 gigabytes, which is huge. No one is ever going to get more than 4 gigabytes. You remember what Bill Gates allegedly said, I don't believe he ever really said it, that no one needs more than 640 kilobytes of RAM. It was basically the same idea with vSAM. 4 gigabytes at the time it was developed was massive. No one could imagine you'd be getting anywhere near that size. Of course, these days, we laugh about it. Our smartphones have much more than 4 gigabytes of RAM. Now, the vSAM limit itself is, as all things in DB2, not as simple as you first think. It's actually split into different limits that the DBA and DB2 must work with together. The way it works is you have simple and segmented vSAM linear data sets, which I'll call LDSs from now on, so I don't have to keep saying linear data set. And this in DB2 is limited to 2 gigs. A partition space, which you can allocate obviously at the partition level, is 1, 2, 4, 8, etc. gigabytes. The larger size than 4 gigabytes, then you have to talk with your storage administrator and get your data class in SMS defined as extended format and extended addressability. Without those two attributes set, your vSAM dataset cannot extend larger than 4 gigabytes. The problem here, of course, is DB2 doesn't know this, and so it will happily believe that you have telephoned, opened a ticket, passed the work through, done the data class change, and actioned it until it tries to allocate it. That's when the problem will happen. And then we have non-partitioned indexes. Now, when they first came out, they came with this wonderful thing called piece size. Now, piece size is terribly misunderstood and is basically hated by most people. It started at a limit from 256K up to a few gigs. Now, as you can see, it goes up to a ridiculously size. Thankfully, you can allocate the piece size in megs and gigs, so you don't have to type in crazy numbers. But the piece size is the size of the pieces of an NPI, or an NPSI, a NIPSI, as it should be called these days. Now, the problem is, of course, that in those days, you couldn't have a DS size of NPIs. DS sizes, up until version 12, came along with RPNs, and we'll get into that later. The DS size was only for the size of a partition of a table space, not for the indexes. Yeah, and this, of course, has now been fixed, so to speak, in version 12. Now everything has a DS size, and so piece size can actually now disappear. We don't need to worry about piece size anymore. But of course, it's still there. And so you have to bear in mind that piece size is there, and the piece size is the allocated maximum size of a part, that's why it's called a piece, of an NPI data set. And any value which you're using, which is greater than 2 gigs, requires a DS size, or even, if you want to go real retro, large on the table space definition. Please do not use large. Do it by DS size. Large, still there. It's still nailed to its perch like the parrot, but one day it will disappear. You shouldn't use it. Use DS size. That's why DS size was invented. So we didn't need things like large on our create table space definitions. And all this is a little bit complex, and of course it gets worse, because then you have simple questions like, how many pieces can my index have? And the answer to that is this very simple calculation, which is the minimum of 4096, or 2 to the power of 32 divided by the DS size of the table partition divided by the table space page size. So I've given a couple of examples there. You can read that yourself, but it's not exactly simple. Yeah, so in other words, the geometry of the table space involving its page size and DS size had a direct implication on how many physical data sets your NPI could have. And it's not exactly simple. Even I cannot work that out dead easy. I've got to get a calculator out and try my best. So it's pretty messy. Then along came DB212 FL500. I like to see it in the questions that a lot of people have gone there, because they finally now come out with what I look at as one of the best things they've done since the beginning of large objects is RPN, relative page numbering. Just for PBRs, of course, but it gives you a variable DS size at the table partition and also a variable DS size for the partitioning indexes. And the DS sizes that you use does not have to be a binary number. So you're not trapped in 1, 2, 4, 8, 16, 32, 64. You can put 42 in if you want to, just for the heck of it. Now, to handle this, of course, they had to change the internal geometry again. And they had to increase the RID size to 7 bytes. Now, this, of course, is, as the Americans would say, a pain point. In England, we call it something else. But the problem is with this change, you cannot do it at the partition level. You're changing all of the headers, all of the partition headers, all of the data in the header pages. The RIDs all get increased, which means you can only do it at the table space level, which for the objects we're talking about here, 1,000 partitions, all of them at 4 gig, is pretty tricky to do. IBM are working on it. They keep coming out with APARs and fixes and recommended ways. Harkin Roberts discusses it at the IDUGs. It is getting easier, but it still hurts. The best thing about PBR RPNs is if you create them new in DB212 FL500, then of course you've got it from the get-go. You don't have any worry about it. However, do not forget, the SMS rules still apply. SMS is separate, and so you still have to do the extended format and extended addressability to the storage group that has the control, if you like, the data class of your RPN data sets. And of course, the side effect of the 7 bytes is it completely decoupled the calculations of page sizes, partitions, and all the rest of it. Yeah, thankfully, that's all gone. That makes life very much easier. So I can only recommend, if you can, and you're in 12500, only allocate PBRs as RBNs from now on. It's definitely the way forward, and it makes your life so much easier. So all these data set limits that we just discussed, they all then flow into the LDS arena, remember? Linear data set. So a simple or segmented space can only have 32 data sets. Then it's game over. You do not get a warning from DB2. There is no ifkid. There is no console message. There is nothing that says, guys, you've just allocated your 30-second data set. You're about to die. It doesn't tell you. A non-partitioning index, as we've just discussed, can have a number of pieces. What that number is, you have to work out. DB2, of course, knows it, but it's not going to tell you when you've reached it. It's just like the number of LDS on your simple and segmented. A lob space can have 254 data sets. Remember lobs? Yeah, lobs are single data sets or single objects allocated at the partition level. So if you have a lob in a partition, each of those lobs can have 254 data sets. This, of course, can create a vast amount of lob data sets, but of course, again, more than 254, not allowed. You die when you have more than that. And of course, finally, a partition can only have one data set. The moment that partition data set is full, you cannot insert anything else into that partition. There is no possibility to suddenly say, oh, I've got another couple of million rows and they've got to fit in partition 6. It's not going to happen. Yeah? And so you have to be aware of these limits. So that's the first set. Those are the real bad guys, so to speak. These are what I call the VSUM limits, dating back to the underlying sort of technology that DB2 uses for its physical objects. And so you've got to monitor. You have to monitor the number of linear data sets that are simple and segmented and lobs. You've got to be warned before you run out of space. If you've got 32 linear data sets, the reorg is not going to be trivial. It's going to be big. And so you want to be able to do that reorg, plan it months in advance, get your outage, your long weekend, Easter, whatever, Christmas. It's going to take a while. Partitioned objects are, of course, a little bit different. You have to watch each partition. How full are your partitions? Because at the moment, until you get to RPN, the DS size is for all partitions. And if you want to allocate more space, you have to then do a reorganize the entire table space to action that DS size change. Again, non-trivial, bit of a problem. And so you've also got to monitor your indexes of those partitions and how many pieces. Yeah. So is that all that you have to monitor? Is that all the limits that you really have to care about? No, of course not. That's why I'm here holding this presentation. Because, of course, we also got the PBG, Partition by Growth, Universal Table Space. Just like the PBR is a Universal Table Space, and IBM Development have said time and time again, they are only going to add new features and new functionality to Universal Table Spaces. Basically, they're pushing us all to go away from simple, that's gone already, and segmented, multi-table table spaces will be gone, and then we'll all be just using PBGs and PBRs. Now, a couple of extra problems with PBGs. Of course, you're not allowed a partitioning index. It's basically a huge container that you just throw data into, and it keeps allocating new partitions as it goes along. So a partitioning index is physically impossible on one of these beasts. You're only allowed an ipsies. And of course, with PBGs, you have the limit of max partitions. Now, some people say, oh, I'll start with 4096 and I'll never have to worry about it. They all got bitten really badly back in version 10 because of various nasty problems. And then it came back, perhaps you should start with like 6 or maybe 32 and see how it goes. But remember, the max partitions is then basically your new linear data set limit. If you've got max partition 6, the moment that 6th partition is full, game over, you've hit the buffers. Yeah, so now you have to monitor them all. And I would also recommend that you don't just monitor when you've allocated your last partition, but how full that last partition is, just like you would normally monitor your normal partitions to see how full they are. So with PBGs, you have to do it twice. So now we're checking all the LDSs for all the sizes, for all the different topography, all the different mechanics. So now everything's groovy, yeah? Now everything's green. We're happy. Nah. We're never happy. Next problem comes walking around the corner. Think SMS copy pool sizes. Now, of course, normally with flash copies or even with normal image copies, you need a lot of space. And you have to make sure that you have enough SMS copy pool size to actually copy all the data you want to copy. And as I mentioned here, what happens if your copy pool isn't really a pool? What if it's only a puddle and all of your copies don't physically fit? Normally, of course, this is a job which you would hope is done by your storage team. But I like to think control is sometimes better. And so I reckon it's a very good idea to actually look at your copy pools and make sure you have enough gigs or percent free to guarantee that the copies that you're doing, which are required for audit, for recovery, for running your system, can always be guaranteed to fit in your copy pool. And if you start running out of space, it gives you a heads up where you can then contact your storage people and say, guys, I need a few more packs at the moment before we can throw away these old image copies with a modified recovery. Yeah? And so that's the idea of this, to give you the ability to just look a little bit outside of your normal area of expertise. That's the limits through the machine. Running through, nice tempo. Now we have limits through logic, because of course there's limits everywhere. So now we have, you might know the English TV series Little England, yeah, Little Britain, where the guy says, computer says no. This is what we're talking about here. The classic, of course, is sequences. You run this sequence here that creates the Roy test sequence ascending, looks great, everyone's happy. Yeah, max value 999, gets to 10,000, super, what's going to go wrong? Problem is, the default, just below the max value on this screen, is no cycle. That's the default. And no cycle means, boom, you get a minus 904 once all those values are used. So the question is, are you checking your sequences? How close are they to actually hitting the edge of the, or the end of the buffers? And for sequences, there's actually more. If you look there, you can see that you have an alias for a sequence, you have identities. Now remember, an identity is a table column-based sequence. A sequence is a user-defined sequence. An X is an implicitly created doc ID column. Now, normally, I've never seen the doc IDs come anywhere near the end of their cycle. But identity columns, yes. And sequences, also. You want to make sure that all of your sequence types that are on this screen are regularly checked to make sure if they're defined as a small int. Oh, hang on. Now we have to look. Lots of them. I'm speaking ahead of myself there. There was, of course, a time before sequences existed. Now, in those days, what people did is they wrote their own. They used small int, integer, maybe even decimal. Remember, big int didn't exist in those days. And they used those in the primary key of the table, just like people use sequences now to get the unique ascending keys. Yeah? And doing exactly what a modern sequence does. And so the trouble is, these things aren't defined as sequences. They just happen to be numeric primary key columns. Yeah? No one is going to update these things to be real sequences. Are you crazy? You're talking about logic and programs and SQL from 1980, tralala. No one's going to change that. And so you have to find all of these possible small and integer and perhaps even decimal fields where you could also be running out of room. Yeah? And here's the room. Your numeric primary keys will vary within this range of small int, integer, unlikely that you're using big int, but I put it in there for completeness, and then decimal. If your stuff is approaching within, say, 5–10% of these limits, the minus ones if you've got a descending sequence, of course, positive if it's an ascending sequence, you want to be told, because you've got to decide something with the application development team pretty quick, what you're going to do when it hits that limit. You do not want to hit the limit in production. That would be, as they say in American, in IBM speak, suboptimal. So, but what are you checking? Even if you're looking at this data, are you getting it from the DB2 catalog values? Because if you're reading it from the catalog, it's very quick, but you're reliant, massively reliant on when was the last run stats executed on that object. Or are you going to do it, I would say, properly by selecting dynamically all of the data that you need from the user data itself, so you get the real values without having to do expensive run stats or relying on run stats. If they haven't run statted for a year, the data in the catalog is a year old. You don't want to be betting on that. But as I mentioned, it's all horses for courses. Your mileage may vary. It's your choice. But I would go for the user data select. It's the safe way. You're really looking at real values. No sampling, no year-old data. So now we have limits through design. We finish now with the logic. We're coming through to the design phase. What design things are there with DB2 that can cause us grief? And there's a few of them. And we're going to go through these one at a time and have a look. Columns in a table. Unlikely to hit it, I must be honest, but you're limited to 750 or even less depending on view definitions. You want to check this every now and again. I wouldn't check it every day. That would be pointless. But you just want to make sure, are you approaching the maximum number of columns for your tables? Because otherwise, that alter add column that you promised your boss is going to fail horribly, and you do not want that. Columns and index is much more fun. DB2 allows 64 columns. The byte count varies depending on whether the index is a good old-fashioned partitioning index, so a PI, or any other type of index. The calculation also depends on whether that index is defined as padded or not padded. And then also about whether it contains null columns, varchar style columns or var graphic, and decimal float. Now decimal float is brand new, came in FL505, and this screen is wrong. I've actually today done a test. I've sent the data off to IBM, and they've confirmed that they're going to correct it. The problem is the calculation is not 255 minus n minus 2m minus 2d, it's minus 3d. For whatever reason, the amount of space which it says that the index takes is 16 bytes, but in the actual index dataset page set itself, it's 19 bytes. Or it's 8 bytes, and in reality, 11 bytes. So for every deck float, you have to add 3 bytes extra, not 2 as it says in all the documentation. They'll get that fixed. It's a minor point, but you have to bear that in mind. We're talking about bytes here. We're 2019. We've got the Z15 launched. We're still talking about bytes. It's like year 2000 all over again. Yeah? So now, next index. For any others, you get a size of 2000 bytes minus all of these things. Yeah, so remember, not minus 2D, minus 3D. Yeah, so we're still talking about bytes. Okay, for these indexes, you've got much more room. 2000 bytes is much better than the other index size, of course. So how many bytes long is your index? Yeah? The question is important because DB212 has now got the fast traversal block, the FTB. A lot of people call it the fast index traversal. At one point in the future, it'll settle down. We'll have one common TLA, a 3-letter abbreviation, about what this thing is. But the idea of the FTB or the FIT is to have this, like a small portion of the buffer pool that is used then, based on the machine hardware lines to avoid cache misses, a very fast lookup of all the data needed for random access. It's like a really, really hyper-performance special buffer pool for indexes. But, like everything in life, it comes with buts and ifs. It's got to be a unique index, and it can have a maximum length less than or equal to 64 bytes. We're back at the byte counting again. 64 is the absolute max. You're not allowed to use time zone. If you have timestamp with timestone, it's not valid for FTB usage. And if you have any versioning, it's dead as well. So you have to keep all this in mind if you want the benefit of FTB. You might have an index where you're thinking, why is that not being used? Perhaps it's one of these limitations. These, again, are limits. And so at one point, some DBA will say, hey, I want this 1-byte column included into my index so I can get index-only access. One of the easy, quick wins that most people go, yeah, okay, we can do that. It's not going to be too bad. That 1 byte has just pushed your index to 65 bytes. Boom. No longer valid for FIT usage. In other words, you have to check before you do any alters on your index of altering column types or adding include columns or whatever. Is it being used by FTB FIT? And if it is being used, will your alter then kill it and push it over the edge? Because then you have to think twice about doing that alter. And it's good to know beforehand. So do we have a database limit? And yes, indeed, there is. Not many people know it. It's actually 65,217 databases are allowed. Back in 5.1, which is the earliest I could find on the internet, it's only 32,511. But I must be honest, you're never going to hit that. But what you can hit is a lot of people create implicit table spaces. And implicit table spaces create an implicit database. The implicit database is like that nasty brother-in-law that comes to parties and hangs around. He doesn't drop off on his own. He stays to the end. And what you got to do, you got to look for all those DSN 0000 style databases that have no table spaces. I call them zombies. And you got to clear them up. You got to get rid of them. Just drop all those databases. What about objects? There's an object limit. I hit it just the other week. All you can have is 32,767 OBIDs in a database. That's the absolute limit. Any more than that and bam, dies. Now remember, the OBID, the object identifier, is not one-for-one. For every table space, index, or RI, you get 2, whereas nearly everything else needs 1. And so you have to make sure your databases are not knocking on that door. Otherwise, just adding an index or adding a table or adding an aux for log or whatever could cause you to hit that hard limit, and it is very nasty to get around that. Very, very bad. So you want to make sure you're checking those. Then we have death by DBAT. DBAT is one of those great things. If you run out of DBATs, you know what happens, yeah? The telephones start ringing. And you might think, well, it's not too bad. I could just do a display DDF detail and, I get my list of DBATs. No, of course you don't. It would be too easy if that worked. The problem is the DBAT counts are only output when you do a display, of course, are the local DBAT counts. Now, I bet everyone in production in the entire world is using data sharing. And of course, at that point, you are only seeing the DBATs that are connected to the machine where your display actually runs, which is as useful as a one-legged man at a cake kicking contest. Yeah, it's not that good, pretty useless. I go to a shop that's 16-way data sharing. You can imagine how many connects you have to do to try and get all 16. But this is an example from a data sharing from one of our test systems. There's nothing going on. You can see it's pretty empty. But it's a nice bunch of data, and this is the data that you have to look at and parse. And so here in the next one, you have what you can do. Either you write a Rex that runs round-robin style of displays and then passes the data, or you're going to have to get warm and cuddly with the IFI command processor and do it with the IFI. IFI can issue the display command at the scope global, which means, scope group. And that means it can actually do it for the entire group. It talks through the coupling facility for you, so you don't have to do the round-robin stuff. Then, when you get the data back, you only have these two interesting numbers. There's a ton of numbers in there, and I can imagine if you're interested, you could add all that into a performance database to get even more information. But the MDBAT and the ADBAT, those are the ones that are interesting. If you're approaching 80% of your MDBAT, you want to get a warning. And you want to check this at least every minute, maybe 5 minutes, depending on how often things go wrong. You want to see whenever your DBATs are running out. Yeah, you do not want to hit the DBAT queuing. You do not want customers to be thrown out. That is very, very bad. That's why you're going to have to do something with DBATs. Future directions. This is the bit where I'm going to talk about the crystal ball. We're nearly finished, so no worries. IBM keep lifting the limits. They've been doing a fantastic job over the years. We remember version 8, or most of us remember version 8, where they lifted the sizes. That was the huge change. Version 10, with a whole massive raft of changes. Version 7, with real-time statistics. There's been stuff over the years which is phenomenal, but the best thing I think they've done, as far as I'm concerned, for limit breaking is the RPN. As I mentioned right at the beginning, the pain point with the RPN is the table space level reorg with table partition level inline image copies. Without that, it will fail. You have to do that. And of course, if you're going to tape, do you happen to have 4096 tape units handy? Nah, this is the problem. So you need a lot of disk space to be able to do this because, of course, the only things where it makes sense to go to RPN are the huge partition spaces that we all have today with billions of rows. As this is a serious pain point where IBM are working still. Yeah? There's also, of course, a new mapping table. If you remember right at the beginning, I said we've got a 7-byte RID, so they've changed the mapping table again, guys. Don't forget to do that. You've got to change it to the new star mapping table, otherwise it can't work. But of course, once you get there, the grass really is greener on the other side. Why? Because you can alter the partitions on the fly with an immediate alter. So let's imagine you've got a SAP transport coming in and it's hammering partition number 5. If you've got a little bit of software written that's monitoring the IFKIDs, it can dynamically alter that DS size for that partition and say, oh, you're getting full, I better give you another 4 gig. You're still getting full, I'll give you another 4 gig. And perhaps you write some software that says, I'll do that up until you've had that 6 times. Otherwise, I presume someone's doing a Cartesian join and I shouldn't be doing the alters anyway. And so this, of course, is a fantastic idea, and I absolutely love it. Are they going to raise any other limits? Yep, I'm sure they will. One I really want them to raise, and I think I mentioned it a little bit, is the FTB FIT. 64 bytes, unique, is a little bit weak. Now, you can understand why they've done it with the cache lines, and if you look in the technical write-ups and stuff which you can get from IBM or IDOG, you can understand exactly why they've written it at that size and why they've written it that way. But I am hoping that the feedback they've had from all the customers so far will enable them to push this to the next level, to say 128 bytes, or maybe even 256, or perhaps duplicate indexes to be in there as well. Versioning I could live with. Time zone I could also live with. I hate the idea of timestamp with time zone. But those two other limits are a major pain point, I believe. And so I would love it if they could ever fix that. Of course, I should open also an AHA idea, or an RFE as it used to be known. But as a vendor, they'd probably laugh at me. Anyone listening to this, get on there, raise an AHA idea. Even if you haven't got to that FL level where you're using FTBs and FITs, it will not hurt to ask. And that's it. I'm through. Do we have any questions from this sort of brain dump of a presentation?
Didn't see any questions come through. I've been watching, and there's nothing there.
Then I must have explained it perfectly.
I think you did. I think there's an awful lot of things that people need to go away and think about a little more. Certainly the RPN stuff is nice to see.
The RPN stuff is great. And I'll be holding this presentation at probably at the IDOG North America, definitely at the IDOG Rotterdam. And so obviously people can contact me by email or however if they want any more details.
I actually do have a question on that came to mind just now. I work a fair bit with SAP, mainly on LUW, but I know there are people out there with SAP on ZOS. I went through and looked, and there was 83,000 rows and sys tables, around 73,000 tables.
Yeah.
You're talking OBID limit of 32,000. How do they get around that, or do they?
Well, they do, because they have, luckily, not all of those tables are in the same database.
Okay.
They're in the same DB2 system, but they're all in separate databases.
Okay. They get around that, yeah.
Because that's the major structural difference between Linux, Unix, Windows, and ZOS. Yeah, ZOS is, you have multiple databases, whereas in LUV you just have the one, basically.
That's right. Yeah, we have a
Yeah, that's the major technical difference between the two systems. And so what they do is they just have an absolute shed load of databases, which are all full of these things. They also have, of course, the bonus, if you like, of they've defined nearly all of it as defined no. Yeah, so the objects are there in the catalog, but physically they don't actually exist.
That's very true.
Yeah, a typical SAP system on the mainframe is like Swiss cheese. It's mainly air.
Yeah, there's a lot of that, but I went through and looked at the tables that had at least one row, and there are 20,000 tables with at least one row.
Yeah, 20,000 tables is not bad. It's but that's okay. That's not a problem for the mainframe. The problem that you have, of course, is to actually be able to take the time to monitor and check and find these limits. That's the problem.
Absolutely, and you've done a good job there. But if there are any other questions, we'd be happy to see them. I don't see them on the tool, and in which case we'll wrap up and thank. I'll take control to be able to do that wrap up. We'll do that right
Okay.
now. And we'll just clicking on the wrong buttons here. let's try this again.
Yeah, thank you all for your time and attention.
Yeah, and here's my screen back.
Yep.
And just click on this. Oh, we don't have a commercial in these shows, but we like to remind people, though, that almost, I would say 75% of our Z audience for the Db2Night Show are also Db2LUW folks. And when you get to a point where you're going to be taking your performance on Db2LUW to a higher level, please consider DBI as a vendor for tools that help people make Db2 run, LUW run a lot faster. And with that, that gives us our wrap-up screen. Oh, I've got my last polling question I got to do as well. So let me find it here. And that last polling question is one of the most important things we do, which is just asking people if they learned anything today. And people are always, it's always good to see that we find that number is always over 90. And like today, the number is a whopping 100%, which is great. And, I actually do have a whistle specifically for hitting a limit and how people feel. There you go. You never know when you're going to need a slide whistle, and you're going to have that available.
I'm off for a beer.
I'm sure you are. And
I'm allowed to. I'm in Germany.
It used to be in Canada. We used to have Fridays where we'd go out for a tipple at noon, as long as you didn't have anything too important going on in the afternoon. That worked out very well. Thank you very much. I'm going to thank everyone for attending, and thank you again, Roy, for doing such a great job. I'll be posting.
Oh, thank you. It's a pleasure.
And we look forward to having you back in the near
future.
future.
Sure, no worries.
And
okay, bye.
Bye, all. Here comes the music. Cue the music. Cue the weekend. And hope everything goes well. And I'm off to speak next week at the Toronto Data Technical Summit, the IDUG Summit on Monday, Tuesday here in Toronto. And then later in the week, we'll be having another meeting here as well. So it's going to be a fun and action-packed week for me next week, and hopefully for the people attending that. Take care. Bye-bye. And we'll see you again soon.